Hello everyone, let's go over population proportions to sample tests. All right, so first things first is this should actually say sample right here, so just get rid of that. This should say sample. And we will have a proportion corresponding to the first sample, which is x sub 1 over n1, and a proportion corresponding to the second sample, which will be x2 over n2. This is all information that we need, this, and this, going forward in the test. So we want to make sure that we can find those elements. Also, we have something called the combined population proportion, which is notated P sub C. And that is just us adding x1 and x2 together over n1 and n2. We just combine those things. This is really important for our standard deviation formula for this particular test. All right, let's go through the 9 steps test together. Step 1, since this is a 2-sample proportion test, we're going to define our parameters that we're estimating, which is pi 1 and pi 2. This is going to feel really familiar to the last couple of days. The null is that they can be equal, and the alternate is as it's been. Either the proportions can be less, one can be greater, or they can not be equal. For conditions, we do need to check all of the conditions for both samples. And these are the conditions for categorical data. And those conditions are as follows. The samples need to be random. And of course, we have to check for normality. But remember, normality with categorical data is doing n times p being greater than or equal to 10, and n times 1 minus p being greater than or equal to 10. And that needs to happen for each sample. And last but not least, n is less than 10% of the population for each of these samples. All right. Step 5 is we set an alpha value, and step 6, we write the formula. Again, this is called a 2-proportion z-test. And here's the formula we would use to calculate our statistic, even though luckily we're gonna use our calculator. P1 minus P2 over P sub C minus 1, P sub C over N1, plus P sub C, 1 minus P sub C over N2. It is important that we know, hold on, this is a 2. It is important that you know this formula just in case you have to use it or you're asked, like in a multiple choice question, to find the standard deviation. So you definitely do need to use this formula, even though our calculator will help us a lot. And then business as usual, evaluate the formula. We're going to go to stat tests. And down here, if your p-value is greater than alpha, we fail to reject. And if it's less than or equal to, we reject the null. All right, let's go to our first example. Example 1 says, the National Highway Traffic Safety Administration published the Motor Vehicle Occupant Safety Survey in March of 2000. Their survey of seatbelts use asked 3,569 males and 3,893 female drivers, when driving this vehicle, how often do you wear a seatbelt? In response, 74% of male drivers and 84% of female drivers answered all of the time. Is there a significant difference in the percent of males versus females who wear their seatbelts all the time? Okay, let's run the test here. So we're going to start off by defining the parameters we're looking for. And pi sub 1 would be the true proportion of male drivers who responded all of the time. Sorry, I ran out of room. And pi sub 2 would be the true proportion, repeated, of female drivers who said all of the time. Okay. The null is always pi 1 equal to pi 2, and the alternate is asking, is there a significant difference? So that just means, are they the same or are they not? There are some pieces of information that we do want to know before we proceed. That's going to be that x1, n1, and p1, and x2, n2, and p2. Sometimes, depending on the type of information you're given, you could have different pieces of this, but you can always find everything out that you need. So right here it says we asked 3,569 males. That's going to be N1. And 3,893 females is N2. And in this case, we're actually given the proportion, 74% of males, so 0.74. And we're given the proportion of females, 0.84. So in order to find that x1 value, we just need to take 74% of n to find out the actual counts. That's what we need in order to use our calculator. So 0.74 times 3,569 is approximately 2,641, just round appropriately. And 3,893 times 0.84 is approximately 3,270. Okay. Step 4, we're going to check conditions. So we're going to check for the males, and we're going to check for the females. Okay, part A is the sample random. It doesn't say, but we're going to assume. Part B, we have to do separately for each. So N for the first one, for the males, we've got 3,569 times 0.74 being greater than or equal to 10. 3,569 times 0.26 being greater than or equal to 10, and both of those are true. For the females, we've got 3,893 times 0.84 greater than or equal to 10, yes. And 3,893 times 0.16 being greater than or equal to 10, that's true too. C, for males, 3,569 is less than 10% of the population, and 3,893 is less than 10% of the female population. 5, let's set alpha, when in doubt, 0.05. Name our test. This is a 2-prop Z test. And here's my formula. Okay. Now I'm going to grab my calculator and I'm going to go to, let me just write in the calculator pathway here just in case. Stat tests. And the 2-prop Z test is option number 6. And what I'm going to do is I'm going to input these values, x1, n1, x2, n2. One thing that's important is that your calculator will not accept decimals in this test. It only takes counts or observations. Oops, not t. And you should get that z equals negative 10.633. Mind your notation. This is 2 times the probability of z being less than. Don't forget, you have to multiply by 2 because we're using not equal to, so we multiply by 2. Since the z-score is negative, we use less than. Negative 10.633, and the p-value for that is approximately 0. That's less than alpha, we're rejecting the null. So our conclusion for this particular problem is that the data suggests there is a difference in percent of males versus females who responded all the time. All right, and then the natural question is, well, how different? So let's move on to find the confidence interval. To find the confidence interval, I just want to remind you that your calculator, it likes to deal with counts, and this should say sample, remember. So P1 is, remember, x1 over n1, and P2 is x2 over n2. These conditions are the same, and they need to be checked for both. Your interval here is called a 2-proportion Z interval, and here's the formula. The difference of the proportions plus or minus the critical value Z and times the standard deviation. It's a little different here than it is on the last one, so be careful. We're not using the combined. And there's our formula. All right, so now I want to find a confidence interval with 90% confidence for the test I just ran. Of course, we have to check our conditions, but we already did on the last page, and I'm not rewriting them, so I can say all conditions have been met. And have not changed. Okay, write the name of the interval. This is a 2-proportion Z interval, and the formula. P1 minus P2 plus or minus that critical value times the standard deviation. All right, now you're going to go on your calculator to, I'll write the little pathway right here if you need to, stat tests, and I believe this is option B, which is 2-prop Z interval. If you notice, it will actually drag over all of the values that you already used before, and your interval should be negative 0.1155, comma, negative 0.0845. And since these are proportions, we do want to make sure that we interpret this correctly, so pay attention to the interpretation here. It's pretty important, and it is that we are 90% confident between 8.45% and 11.55% fewer. That's where we take the negative into account. Well, actually, this is the proportion. So we're 90% confident that, I'm going to fix this. Sorry. Oh my gosh. The true proportion of males who responded all of the time is between 8.45% and 11.55% less than females. That's a little bit better. All right, so the only homework you have tonight is to finish and do this one practice problem. So complete this practice problem to complete your packet, and we'll go over it on Monday. Hope you guys have a great weekend. Bye.